Okay, guys, welcome back. And today we are going to finish up the other two configurations. So yeah, I know the line is not good, still not good. We have tried so many things, but somehow it is still like that lah. So Just bear with me, this is the last time I'm streaming from here. Starting from next week, I will stream from my home. Hopefully the connection will be better. Okay, now so before I start, for this stream, maybe we don't have to do a 2 full hour stream. We can just do a 1.5 hour because we only have 2 more Avenger game to play. And then after that you'll be a routing pro. Okay. Now but before that I'll talk about your lab test first. So okay, now if you are not those people who are sleeping until now, you know that this Saturday you will have your lab test 1. And the format is actually MCQ, so 30 questions of MCQ. And the way you do it is, okay, this is how it works. I'll explain first. If you have any questions later, you can ask in the chat. Okay, so right now 我在上课 Sorry, I have a guest. Okay, now on the day start from 10 to 12, you will get 2 links. Okay, now it is all on Weber. So the first link, when you click, you will get the network. The network as what we have been playing so far. So we have done one Alex the hacker. We have also done Bob the builder. And then today we are going to finish up the Avenger. Okay, so those kind of file, you will get 1 file. And on the second link is all the answer and the questions. Okay, so what you do is, based on the network activity file, you read the questions and you go back to the activity file to find the answers. After you get the correct answers, you go back to the question which is on Weber, just like how you do your quiz, and you answer it on Weber. Okay, so it's just that simple. It's something similar to your quiz, except now you have one extra network packet file that you should open side by side with your questions to do lab test 1. Okay. Now, for the scope of your lab test 1, it is only cover from lab 1 and lab 2. So you will have to know about how to configure routers, of course, and then you have to know about the network services that we have learned in the very beginning of the lab. But it will not cover anything that we learned this week for the routing. Okay, so the lab test doesn't cover for static and dynamic routing. Okay, so now I'll open for you to ask any questions that you want to know more about the lab test. Please let me know. If you're okay, then we'll go back to the Avenger, and today we'll finish up the Avenger game. Okay, now first question. It is not like the packet tracer activity. Yes, you are right. So you still have the network file. It is still like an activity, but you don't answer into the network packet file. You should answer into the Weber, the questions on Weber. Okay, this is the difference here. Okay, of course I know you might be asking, hey, how come we don't want to do directly on the packet tracer file? Okay lah. The simple answer is because I love you and I don't want to make it to be too hard. Okay, you will thank me later lah, so you don't need to know what's the reason. Just need to know that it is MCQ. Okay. Now another question is, do you need to build your network on your own? Okay, you don't have to build anything. You just need to go to the network file to find the answers to all the questions. No need to add any device. No need to remove any devices. Okay. But you might have to do some configurations to get certain answers. That is to answer your question. Now, of course, there's one thing that you should know is you are free to remove or add any device. You will not get penalized. Okay? That means you can change the direction, you can pull the cable to be longer, you can do anything because your score doesn't come from the network file. Your score comes from the 30 MCQ questions. Okay? Now, another question from Simon. So Simon has been very active lately. Everywhere I go, I can see Simon. Okay, now Simon is asking, can I use CLI to configure? Okay, good question. Now, in the packet tracer found on the lab for the lab test, there are a few routers. In fact, there are many routers. Okay, I can tell you straight up front that there are many routers, and there are some routers that you can configure directly using the CLI tab. But there are certain routers that are locked, meaning that you have to configure those routers from a PC through a console connection. Okay, so depending on the questions, really, I cannot tell you how many, but there are some routers that you need to connect a PC to configure. There are also some that you don't have to. Okay. Now, and I have this special question here. There will be a power shutdown on Gampa. Don't worry about that lah. Okay. I hope that it works. I'll find out. So if really we cannot do the quiz on Saturday, then I will let you know again very soon, because I haven't get any notice that it will affect Weber. So hopefully it is fine. Okay, any other questions that you want to know about lab test beside the question itself? You have any other questions about how you do the test or any other thing? Okay, if everything is fine, then we'll go on with the routing that we are learning. So, we only have 2 more to go lah. The other day, what you're looking right now is this is a network that we had earlier, okay, for the Avenger. So this part here, we are already in Avenger 3. So for those who missed the earlier episode, welcome back to another episode of Avenger. You can always replay the stream so that you know why we are doing this right now. So the other day we have learned about static routing. So today we will learn 2 more kind of routing, which is the default routing and the dynamic routing. Now it is not just to configure. We will look into the reason and the intuition behind why we need to learn so many kind of different routes. Why not just stick with static route? Okay, and then you will see that actually it is worth your time learning. Now, coming back to this network here, the other day we have already configured static route to connect 3 networks. So to make it easy, I will now label this network as LAN 1, LAN 2, and LAN 3. Okay. So in the Avenger 1, episode 1, you already configured 2 static routes to link these 2 networks together. And the tricks to static route is always you just have to find the correct next hop IP. Okay, that is the only difficult part. If you get it right, no issues. Now in the second part, we added a new network, and then we also configure static routing to connect all of this network. Okay, that is already done. I remember that it is part of your homework, right, to connect LAN 2 to LAN 3. I hope you have already done so. Now if you haven't done so, that's okay. Today we will start with Avenger 3. When you open the packet tracer file, everything is already configured. So all these LAN 1, LAN 2, and LAN 3, they can already talk to each other. Okay, so right now our only focus is to configure dynamic routing. So I'll explain how and why we want to do so. And for those who have done the lab, I think you know how to configure, okay? But you have to think again, when you know, do you really know? Or if I change the network a little bit, then you don't know. Okay, now that is a problem with people who just type in the lab. You should understand why you are typing that command, okay? Now, first thing is, you have to decide when to use static route, when to use dynamic route. Okay, now, of course, the easy reason is static route, you use it when there are only a small number of networks that you want to configure. A dynamic route is helpful if the network is too complex and you don't want to configure manually for so many different routes. Of course, for exam, it is different. For exam, it depends on the question. The question will say, set a static route or set a dynamic route, then you have to follow. Because you want the marks, then you have to follow. Okay, so that's the reason. And today, you see, the network right now we have is, before this, we already have all these things. And today we added a new galaxy here. So the story behind the scene is like this. So suddenly we realized that actually we are not alone in this planet, you know. So today do I look like Doctor Strange? I've tried to dress like Doctor Strange, but because of the video quality, you cannot feel the effect. Okay, so right now we will set dynamic routing to connect all the network in the yellow color region to the new network that we have just discovered in the pink color region. Okay, I hope you see pink color lah. If you are using the OLED display, then you can see pink color. If you don't see pink color, consider changing to a better display. Okay, this is not an ad. So now, of course, the first question that you want to ask is, can I use static routing? Now, if you say yes, you are correct. You can use static routing. There is no wrong in that, but you have to be very patient. Okay. Now, the reason is because every time you added a new network, you have to do two things. First, of course, you have to go to the new router to configure routing. And then the second thing is you have to go back to all the old routers to add a new path or a new route to this new network. So it's actually a lot of work. Okay, and it get confusing. As the network grow bigger, it get confusing. So some of the time you might miss one or two. And it is not your fault because we are human. Sometimes we just overlook certain routes. Okay, so if you don't want that to happen, you should learn how to use dynamic route. And in this subject, we'll be learning how to configure RIPv1. Okay, now I know some people will say, oh, RIP. I hope you can follow this stream. If you cannot follow how I configure RIP, then you will be the one who will be RIP later. Okay, it's not a nice word to say, so I will just call it as a RIP protocol. And you should know that RIP protocol, there are two versions in fact. So there are RIPv1 and RIPv2. Okay, now in this subject, we are only going to learn about RIPv1. RIPv2, you will learn this in level 2, which is in year 2. Okay, so what are their difference? RIPv1, it is not like because it is simpler or it is harder. No. It's the same one. In terms of configuration, it is the same. But V1 is used for full network. V2 is used for classless network. Okay, now you might be thinking, what do you mean by classful and classless? Remember in one of the lecture, we learned network addressing. And then we say that there are two types of addresses. One is classful, one is classless. So classful address means that you have class A, class B, class C, class D, and class E. Now, the other type of address, classless, or sometimes we call them classless inter-domain routing, CIDR, means it can have a random mask. So remember, classful, you always have A, B, C, D, and E. And with a classful address, the mask is fixed. So this one has to be /8, /16, /24. Whereas for a classless, it can be any mask like /28 or /29 or so on. Okay, now whether you should configure RIP1 or RIP2 depends on the network. If all the network is using a classful address, then you should configure version 1. Okay, now if all the network is using a variable mask, so you have weird mask like /25, /23, then you should use the classless version 2 for the classless. So these are their difference. Okay, the command is actually almost the same, just that how you use it. Now, to make it easy for you, in our subject, there is no V2. So it doesn't matter what kind of questions you get, you always configure version 1. Okay, but that is not true if you go outside. Now, the next thing is, when you want to configure RIPv1, you want to know exactly how it works. So later on, I will show you how you configure. I think you already know this by now if you have done the lab. But the important thing in this stream is that you have to know how it works. So some of you might think, hey, it is so magical. If you think it is magical, in fact, you're right. Because we just need to type so little line of command, and somehow magically, all the networks will be able to reach each other. So there are really magic happening behind. And today I want to show you a little bit of that magic. Okay. Now, first thing is, let's talk about how we configure RIP protocol first. Okay, because you can say a lot, but if you cannot configure, then you didn't prove anything. So configuration is still important. Now, in this adventure tree, we are going to configure dynamic routing protocol RIP1 on 3 routers. So we will do it on Earth router. We will also do it on the Titan router. So this is one of the new router. And then we have a new router, Narnia. Okay, these 3 routers. Later we want to set RIPv1. Okay, now the trick to set RIPv1 is that you only need to configure all the network that is directly connected to a router. So for example, if I take Titan as example here, when I want to configure RIP, I need to know how many networks that is directly connected to me. Okay, so I will color this for you here. For Titan, I have one network here. This is the second network. Okay, let me use a different color here. So this is the second network here, and then you have a third network here. That is for the Titan. So when I configure RIP1 on this Titan router, I need to remember I need to type 3 line of command, okay, for each of the network that is directly connected. Now, if I take Narnia as example, so let's say I want to configure Narnia. Very simple. I only need to configure for this network here, number 1, and this network here, number 2. So you can tell from here, RIPv1 is convenient in such a way that it doesn't matter how complex the outside will become. As long as I take care of myself, I know how many network is directly connected to me, I'm good enough. I don't want to worry about what people think about me. You are not handsome enough to be YouTuber. Your face is not like Korean, you cannot be YouTuber. We don't care about that because we only care about all the network that's directly connected to me. Okay, so you see, if one day this one become like this, wow, become like a jungle, so complex. But when I configure a RIP1 on Narnia or on Titan, I don't care because the number of directly connected network to me is still the same. It doesn't add yet. Okay, so do you get the point here? RIP is very convenient because we only care about our own network. Now, the next example here, the last router that we want to set today is Earth. So Earth here, if you really want to see how many network that's connected, you have to be careful, don't miss out any of them. Okay, so over here I have one network here. Okay, it is supposed to be like this, so I will draw the whole network boundaries properly for you. Okay, now after this you have another network here, and then you also have one more network here, and then you have one network here. So in total you actually have 4 directly connected networks. So what it means, when later I go and configure RIP1 on Earth router, I need to type 4 lines. If I type 3 lines, means something is missing. Okay, I forget something. So it's really that simple. Now, we'll go back to packet tracer file. We'll configure this together. After that, I will explain to you how this thing magically works. Okay, so if you're ready, let's open up your Adventure tree, and we'll now configure routings on these 3 routers. Okay, now I'm looking at the network here. So what you really want to do is you want to start one router at a time so that you don't forget to configure. Now for my case, I will start with the Earth router. Okay, so what I do is I click on Earth, and then I go to the CLI here to configure RIPv1. And because this is a routing protocol, you have to make sure that you should go to level 3 to configure a route. So you go config T, and now I'm in level 3, and this is where I can start to put in the router RIP command. Okay, I hope you can see put in the router RIP command. Okay, I hope you can see if the quality is really bad, then perhaps I will just read it out. Okay. Now, next thing here, for you to configure router IP, you need to use the command router rip. So this is the command, just simple command, just remember them, and followed by the keyword network. After this, you want to put in all the network address for the network that is directly connected to you. Okay. Hey, focus. I know we have an intruder, but don't pay attention to that. Okay. Now over here, based on what we discussed earlier, I need to type 4 lines. Okay. But there is a trick for you to configure this. Okay. Remember that earlier when we learned routing, we say that if you do show IP route, you will see all the network, all the routes that is on this router. Now, luckily for us, one kind of the route that you can see in the routing table is C, which stands for all the directly connected network. Okay, so what it means is that since I want to configure all this C into my router RIP syntax, the shortcut here is you show the routing table, and then from the routing table you find all the C, and you type in all this C into your configurations. So if you do so, you don't have to manually think what is the network address, because the router already tell me all the network that is directly connected to me. Do you see that? Which is cool, because remember we say that a router, if you connect a network, if it is direct, the network address will always show up automatically. So in this case, I need to configure for this network 110. I need to configure another line for this network here, and then this network here, and this network here. So in total 4 network. Okay, if you cannot remember, you can actually write this down on. So I will go back to the config here, router IP. Then you just put in network, and then you do one by one, line by line. Okay, you want to choose the line with the C, the code C in front. The one without C you cannot type. Okay, hey, listen properly. You don't want to get confused, so you only type the one with C in front. Can you type this one? Hey, hello? Cannot. Okay, hello? This one. Hey, wow, now it's very famous. Hello, you cannot type this one. So I will start with the first one, 110.110.0. Okay, and then I go to the next line here, 192.168.1.0, and then I go to the third network here, 192.1. No, this is not correct. Network 200.200.200.0, and then the last one, network 210.210.210.0. Is it okay right now? Okay, for those who are lagging, you just refresh. If you refresh, it might get better. Okay, guys, for those who is lagging earlier, just refresh the video. Okay, so what I have just done earlier is I already typed 4 lines here, and the shortcut for configuring RIP is that you do a show IP route to check all the directly connected network here, and then you type inside just like that. It's done. Okay, the config is done. So just press exit, and then that's it. Now, if you are like me, you want to be sure you do this correctly, you can use the show run. Like me, you want to be sure you do this correctly, you can use the show run. Now guys, listen up. Right now there are 2 commands that you can use to check whether you set routing correctly. Okay, the first one is show IP route, that will show your routing table. But in this case, if I do a show IP route, you see that there is no changes. is exactly the same as before I configure this router. So you are not wrong, okay? Although you have configured RIP, but you don't see RIP appear here. That is correct. It's not you, it's the router. You know why? That's because how dynamic routing works. Okay? For the RIP to work, you need to configure RIP. The other router, you also need to configure RIP. So let's say if you want 10 router to use RIPv1, you need to configure RIP on all 10 of them so that you can see RIP appear in the routing table. Now the reason I don't see any new RIP route here is because I only set one router with RIP. Okay, now if you go to the next router and then you set up RIP, then you will see some RIP routes appearing here. Okay, so what do you do here is what you can do is you do a show run, and from show run you press spacebar. Okay, you press spacebar for a few times and you will see router RIP. So this is where you check whether you set up RIP protocol correctly. Okay, of course if you set up everything works, then don't check lah. This is for when you set everything, you think everything is right but still cannot ping. Yeah, I know lah, that feeling, I know. Then this is where you should check. Okay, now I'm done with Earth router. Now I'll move on to the Titan router. So I click on the Titan router. I will do the same thing, go into the CLI here and then go to level 3. Okay, before that, remember to show the routing table so that you know all the networks that you need to set. And then I go to router RIP. Okay, so the keyword here is network followed by all the C. Okay, so this is the first C here, 100.100.100.0. So I put in 100.100.100.0. Okay, now the next one here is this one. 110.110.110.0. So I put in 110.110.110.0. Okay, now the last one is 192.168.4.0. So I type network 192.168.4.0. Enter, that's it. So you can type exit and then do a show run to see whether you have set this properly. And in fact, yes, if you see something like this, it means that you have already configured them properly. Now you don't have to worry about why is 100.0.0, why it is not 100.100. This is because, like I said earlier, RIPv1 is a classful addressing. So there are some kind of route summarization that's happening behind, but you don't have to worry about this. This is out of your scope. Okay, as long as you configure properly, that's more than enough. Okay, so when you see 3 lines here, hopefully this is correct. Then I will go to the next router, which is the Narnia router. Okay. So again, I'll do the same thing. I do a config. Okay, I do a show IP route first. So for Narnia, it's actually the easiest one. I only have 2 directly connected networks. So when I set router RIP, I only need to put in 2 lines of the command. Okay. So this is how I set router RIP on Narnia router. Easily, in 10 seconds, you can set this. Okay, now, of course, for those people who want to find manually what is a network address, it will take you a lot of time. So remember this shortcut. This is really cool. I found this by accident. I hope that it is useful. And yeah, just put in all the network with the C in front. This will speed up your config by a lot. Okay. So if you're okay, you do an exit. And then right now, if you do a show IP route, most likely you will see some new routes. Yeah, you see over here. When I do a show IP route, I have all these R, okay, which is not here before. So earlier I only have 2C, 2 directly connected network. Now I have 5R. So all these things happen because of what we call the routing table exchange. Okay, so what this means is that after you set up router RIP on the router they talk to each other, and then they teach everyone else about all the network that is directly connected to them. Okay, so I'll explain the whole concept of dynamic routing using this example. So when we start this Avenger 3, no one else can talk to the new galaxy. So what I highlight here, do you see the square here? These are the new galaxy that suddenly appear. Okay, so earlier I say, of course, you can always set static routing to come to these two new galaxy, no problem, but there's a lot of work, which is why we use RIP version 1. Okay, when after you configure this, if you go to each of the router and then you show the IP route here, you will always see this R. And this means that right now, this router know how to get to all this network by RIPv1 protocol. Okay, which is what we want actually. But the question now is, why this happened? Okay, so if you really think about what we have done, on each of the router, I have typed in all the network address for the network that is directly connected to the same router. And how come all the other router can get to know how to get to all this network? Okay, so this goes back to what actually happened on the router when you type the few line of command. Okay, the first thing is when you type router RIP, the router is building the RIP table. So we call this the RIP protocol table. So let me go back to the visual here. Guys, no choice. I know the line is bad. Just listen. We try to finish this early, and then next week I'll stream from my place lah. No choice lah. The line is like that. Okay, so you have this thing called a RIP table. Okay, you see every router will have a routing table and they have a RIP table when you configure the router RIP. So let's say I use this, I draw this one. This is a RIP table here for Earth. Okay, so you have this one. And then on the Titan router, you also have another RIP table because you already configure RIP here. So this one is Titan. Okay. And on the Narnia router, you also have another thing we call this RIP table. And it is also because you configure RIP. So you see these three tables here. Okay, now every time you finish typing, what will happen is the thing called routing table exchange. Meaning that every router, they will teach their neighbor or their next neighbor how to get to all the networks that is currently directly connected to me. Okay, so you see on the network here, every router will have a few network that is directly connected to itself, but which means that this guy, he know how to get to this network because it is already directly connected. So what the router do is, based on what I know, I will teach this knowledge to all the other router. And then the other router will know, if I want to get there, I know how to get there because somebody told me so. So they are learning from each other. Do you see that? So the idea is like this. Router A, he know a little bit about everything. Router B, he also know a little bit about everything. And when they combine this knowledge together, they know how to get to everywhere on the internet. Do you see that? For example, I give you a real world example. When I go to KL, sometimes I drive myself using Google Map, but I still get lost one because that is KL, okay? Doesn't matter how good is your map, you still get lost one. So normally I will ask one of my friends in KL, can you bring me around? Because he know the KL best, okay? Now, if someone go to Penang, I'm from Penang, so I will say no need to use Google Map, I'll just drive you around, I'll be your tour guide because I know all the places there. You see? So we are actually teaching each other how to get to a certain place, and that is how dynamic routing works. Okay, so in one sentence, dynamic routing works because all the routers, they teach each other how to get to a certain place that they know. Okay, so for example, in our example here, this Earth, okay, you see, Earth know how to get to here. This is number 1. Okay. So you see, Earth know how to get to green color, yellow color, and then you have this purple color, and then you have this blue color. Okay, so this example here, Earth can go to 4 network. So what Earth do is, I will teach the other router. Okay, so this means that this thing here that you see, it will be sent. Okay, it will be sent to him. It will also be sent to him. And what the other router do when they receive this knowledge is they will learn how to get to all the network that they do not know yet. The same thing will happen on the other end. So this one here will be sent to Earth, will be sent to Narnia, and then they will learn from what they know. Okay, so the same thing happened for Narnia router. This information will be sent to the other router, and then they will learn. So in the end, you can imagine that all the router that is using RIP, they have a combined knowledge of all the network from all these 3 routers. Okay, if I want to visualize it, it is something like this. So you have the knowledge from Earth, from Titan, and from Narnia. And this is a very good routing table, because with this routing table, I can get to virtually anywhere. Do you get what I mean here? So this is how dynamic routing protocol works. Do you get it? Okay. Now, for those who have done this and you have configured this, the next thing you can try is you try to ping. From Thanos' PC right now, you should be able to go to Earth already, because now the router know how to get there. Okay, so let's try this together. I am in Thanos' PC right now. I open a command prompt and I try to ping Iron Man 192.168.1.1. And in a short while, hopefully I set this correctly, then you will get to see the reply. So yeah, you see, a reply means it is successful. Okay, Now, next thing you should know is what actually happened when we do this. So actually, when you ping using Thanos PC to Iron Man, I do not know whether they are friends or not lah, but they are acting, okay? They are all actors, so right now they are friends. So when this happens, the packet go to Thanos router. Thanos router will do this. He will check the routing table. Okay, where is Iron Man? Iron Man is 192.168.1.0. So this is Iron Man. Okay, now you see, I can go there because I already learned how to go there. I need to send my packet here. So this is how routing works. Okay, I check routing table. I see how to go to a place I'm trying to get to. Okay, Now, if you're okay with this, we will go to the last playthrough and we'll learn about default route. Okay, I'll give you a few minutes. Maybe you take 2 minutes. Try to recall what we have just learned. And then 2 minutes later, we'll go to the last game of the day, which is Avenger 4. Okay guys, are you ready? If you're ready, then we'll talk about default route, okay, which is another important concept in routing. So remember, we only need to learn 3 type of routing: static route, RIPv1, and default route. Okay, so we are already in the last one. Okay, we get one okay. One okay is good enough. I just need 1 people to trust me, and then I will continue. Okay, now you are seeing the same network here. So what we have done so far is we have already set static routing to connect the 3 original network, and for the 2 new network we use RIPv1 to connect. Okay, so just now when you try, this guy can ping this guy. Okay, but if you try, you use the Thanos PC, you try to ping top, you tell me whether it will ping or not. So let me try this for you. So for those who want to play along, you should open up the last file in the zip Avenger 4. So over here I have okay, yeah, we have a question here. So hi, Jacker is asking, do you need to type the IP hop command? No. You choose only one. Dynamic routing, you use router RIP. Static routing, you use IP route. Either one. Okay. Now you see, I'll just show you that I'm not lying. I will try to ping from Thanos PC. I try to talk to Iron Man. Just make some friend first and then warm up first. Okay, now can ping. Okay. Next thing I do, I ping to Tor PC in the green color network 192.168.2.1. Can ping or not? Anybody who say can ping is lying. Okay, you see, you cannot ping. Now, the question is why? So remember, actually the answer is very simple, because no routing. You see, every time you have 2 or more router, you have to set routing. It doesn't matter static route or dynamic route, just have to set routing. So in this case, why Thanos cannot ping to Tor? That is because all the routing that we have set earlier, there is no routes that go from Thanos network to the Tor network. So I will highlight this for you. Now, the reason this doesn't work is because you have to see how far a router can go. Okay, taking this Titan router as the example, we already set RIPv1, and this RIPv1 allowed this Titan to go to a few networks that Earth already can go. So I will highlight to you all the networks that Titan can go. It's until here only. Okay, all the red color one. So you see, right now, from Titan to Asgard to here, you cannot get inside Asgard yet. Okay, that's one reason. The second reason is from Asgard go back to Titan router. Remember, it's always two-way. When it go back, there is also no route yet. So the way for us to fix this thing is, of course, you have to set routing. Now, the easier way is you go into this Asgard router, you set RIPv1. Okay, like what we have done earlier. And then you go into this moon router. Let me move this up. Okay, and then you also set RIPv1. And after you do so, you can try this on your own. I'm sure everybody is able to ping each other. Okay, that's fine, but that's not what we want to do now. So what we want to learn here is to learn about default route. Okay, so in Avenger 4, our mission is to set default routing here. You want to set a default route here. You want to set a default route on moon. You want to set default route here and here. So 4 routers. Okay, this is our mission. We will not set any default routing on Earth router. and you will know the reason why later. Now, before we start to set, you have to understand. Okay, I will answer your questions later. Hold on. You have to understand what does default route means. Okay, default route, we set this for two reasons. Okay, first reason is as a backup or insurance to routing table. The second reason is to make your configurations easy. Okay, now let's talk about the first one. With default route, we can make sure that all the routers has an insurance in such a way that when you want to go to a certain network that you do not know how, you still can send the packet to a default router, and then the default router will help you to think how to get to a certain place. Now, for example, now from Kampang, I want to go to KL, so I'm driving, but I drive until maybe I drive until Tanjung Mali, and then I do not know how to go. Okay, so I can ask someone from Tanjung Mali to fetch me, and from there to go to KL. Okay, so that's something like a default route. Another example is, I'm not sure about you, but for me, I always have a friend that doesn't matter how I feel, I will talk to him. Like today, I'm so sad because the line quality is so bad. Okay, and then you are not happy because the streaming is not smooth. So when I go back, I will talk to this friend. Yo, today I feel so sad. I don't know what can I do. It's him. Now, when I'm happy, when I get so many views, I will tell him also, wow, I'm so happy I get so many views for my YouTube video today. Also him. So that is that one person that doesn't matter what happened, I'll talk to him. I'm sure you have this kind of friend also. I hope you have. Everybody needs this kind of friend in their life. So you see, that is kind of my default route, my default person. Okay. Now, default route is exactly the same concept for router. Router job is very simple. I get a packet, I have to find how to send this packet to the destination. If I do not know how, there are only two things that can happen. If you are lazy, you will throw the packet away, and then you tell the sender, oh, I'm sorry, I cannot send this packet. That is why you see ICMP error message. So for those who have been doing the lab, sometimes you see destination host unreachable. Sometimes you see request timeout. The reason you see this message is because the router tried to send your packet, but it fails to do so. So he sent an ICMP error message back to you to tell you that, I'm sorry, I cannot send a packet. That's the first thing that happened. The second thing is, if I cannot send your packet, I will ask somebody else, some other router that can send your packet to do so. So I will forward this packet to that guy, and that is a default router. Do you get what I mean here? So it's like pushing the responsibility away. Okay, I have this job, I do not know how to do. I give it to other people to do it. So it is better. In that way, it is better. Rather than you throw the packet away, you tell somebody to do it. Maybe he can do it. If he cannot do it, then never mind. Okay, at least you try. Do you get what I mean here? So you see, every router, you need to have this default route, because no router can have all the routes to all the network on the internet. There are just too many of them. So it is very normal for a router to have destination or routes to a few network, and then for all the rest of the network that it is not in the routing table, it doesn't mean you cannot go. You still can go there, but you have to send this packet to somebody or some router that know how to get there. And that is the default route. Okay, so if you go back to your network here, I will give you an example of how does a default route looks like. So let's get back to your packet tracer Avenger 4. Now I simply take any router. For example, and now I will take this Asgard router. Okay, I will click on Asgard router, and then I click CLI. I want to show the routing table here, so I show IP route. This is the routing table. Now I will ask you a few simple questions to see whether you know what is going on. Now, if today a packet goes to Asgard router, okay, this packet is trying to get to 192.168.3.0. What will the router do? It's very simple. the router will check the routing table. To get to 192.168.3.0, I need to send this packet to this next hop IP 200.200.200.1. So in our case, it is actually the FA01 on Earth. Okay, I try to drag this so that it gives you a clearer view. Otherwise, it is very packed. You cannot see the interface clearly. So this is the Earth router. Okay, so what this happen is the packet will go from Asgard router to Earth router FA01. That's the next hop, and that is how routing works. Okay, now second question: what happens if Asgard need to send a packet to network 80.80.80.80? What will happen? Okay, same thing. He go to check all the routing table, but this time he cannot find 80.80.80.80. So based on current configurations, this packet will be thrown away, which is not good. Now, once we set a default route, later you will see 0000 here. That packet will be sent to this default route. Okay, so that is exactly what we want to do here. So you can do this together with me. Now on the Asgard router, I will set a new default route. So I go to config T, and you should remember that default route is just a special kind of static routing, which is why to configure a default route, I will use back the same IP route command that you use for static routing. Okay, so IP route and followed by 40. Okay, 40 means that this is a default route. When we put 40 here, it means going to anywhere. I don't care, just go to anywhere. Followed by another 40 here, which is the subnet mask for all the network, which is also all the subnet masks, followed by the next hop IP. Okay, so this one, you have to remember how to configure default routing. You use 0000 Okay, now followed by the next hop. Now, of course, next hop IP, by now you are very pro already. Okay, the next hop IP for this case is, okay, try to think. Let me find a better position. It's still too close. This is better. Okay, now look at this Earth router now. From Asgard to get to anywhere, he will send this packet to the Earth router on this interface FA01. FA01. I'm actually trying to get a good view. Okay, it is FA01. Okay, so which means that you want to put in FA01 IP. I go to Earth router FA01. The IP is 200.200.200.1. Okay, so I go back to my config. I put 200.200.200.1. You press enter, then you already finished setting up the default route. Okay, so to check whether this is correct, you do a show IP route, and now you'll see this new line here, which represents the default route of this router. Okay, this line is very important. Okay, now let's see what is the difference. Go back to the example that I gave you earlier. When Asgard need to send a packet to 80.80.80.80, he will check one line by one line. He cannot find 80.80.80.80. But this time, instead of I throw away that packet, I will send this packet to my next hop IP, which is the Earth router. Do you see what is the difference here? So without a default route, a packet will be lost if the router doesn't know how to get to a certain place. With a default route, the packet is safe because it will be forwarded to the next router, and hopefully the next router know how to get there. Do you get what I mean? So this is why we want to have a default route in almost every router. Okay? Now, after this, you might be thinking, okay, now, of course, you have to set default route for every router. That's fixed. Don't have to question that. But there are certain times when you cannot set a default route. Okay, I will show you one example later, but let's talk about the second reason of default routing first. Okay, now just now I said two reasons. First one is this one, what I just showed you, as a backup plan. So you always have a person that is behind your back if you do not know how to get to a certain network. Okay. The second reason is really just to make your configurations easy. Now, if you have done lab 3 this week, exercise 4 you learn to configure default route, you will see that, wow, instead of typing 3 commands, I can simplify it to just 1 command, and then it's do the same thing. Okay, so over here, another example is that I cannot show you an example here. I will show you the example using the lab. Okay, so now I'll bring up the lab here. I will explain why it is important. Just give me a moment. Okay guys, I hope you are still okay. We'll go slow because it is important that you get the concept right. Now, what you are seeing here is the network that you get from your lab 3 exercise 4. And here you learn how to configure a default route. So the reason I repeat this again is because I want you to know 2 things. First is when you should configure a default route, when you shouldn't. Okay, first one, you should configure a default route when you notice that there is a stub network. So what we mean is, do you see a stub network there? So what is a stub network? A stub network is the network that you only have one way to go inside and one way to get out from the network. Okay, that is the stub network. One way in, one way out. So a very simple example is like this. If I have a router 1 and a router 2 that connect to the internet, and then I have a PC here. Okay, over here I can say that this is a stub network. Why? Because doesn't matter where I want to go on the internet, the traffic will always go out from the same way. Okay, anybody from the outside want to go to this PC, it always go to the same way. So you see there is only one way to get inside the green color network, and also only one way to get out from the green network. And this is called a stub network. Okay, go back to your example here. I can tell you that actually over here we have 4 networks, so I'll just color them for you. Now since you are here, why not I just ask you a question, okay, to wake you up a bit. How many network do you think I have here? How many LAN that I have here? Someone please try answer on the YouTube chat. I hope that at least somebody is replying. Tell me how many LAN do I have here? Hmm. 4, 3, 5. Very good. At least you try. Try is the first step to success, you know. Okay, a lot of people say 4. 11 that 11 guy you are from the future already we are not so far yet. But anyway, good try. Okay, the correct answer is 5. 5 because you see over here this is another network. So I have already colored for you. Over here you have 5 LAN, or we say 5 network or 5 subnets. Okay, so those who answer 5, congratulations. 1, 2, 3, 4, 5. Yeah, 5. Okay. Now if you don't get this right, it's okay. But if I ask you another question, how many N network? So this is a bit different. If I say network, then you have 5. If I say N network, then you have 4. So N networks are all the network that you have N devices inside, like PC, like your phone, like your server. So all these are N network. Okay, you have 4 N network here, and you have 1 which is not N network. The one that is not N network, we call them a core network, or sometimes it is called a backbone network. Okay, backbone. So we have 1 here. This one, we have 4. The middle one is only 1 network. It is not 2 network. Although you have a switch in between, in the middle, right? A switch doesn't create a new network. Remember, a switch is still within a LAN. You only have a new network when you connect it to a port on the router. So actually, this one here is considered as 1 network only. Okay? I'm very sure it is 5 network. You are scaring me. There are only 5 network here. So the network is as what I color to you here, okay? Now, if you still do not know how to count how many networks, that's okay lah. You just need to know that every time you have a router, connect to a router, there's 1 network. But in this case, because this 4 router is connected to a switch, they are all considered 1 big network. Okay, so come back. We want to know what is the start network. Now, before that, if I talk about static routing, you should know that static routing is very troublesome because you need to set 1 route, 1 static route to each of the destination network. Okay, so coming back to this one here, my next question is, if I am configuring router 0, okay, how many static route I need to configure? So I'm configuring for router 0. I need to set 1 route to each of the destination that is not directly connected to me. So for router 0, when I set a static route, I need to have the first route going to LAN 2. Okay, we call this LAN 2, LAN 3, LAN 4, and LAN 1. So this is the first route. When I set static route, I need to go to LAN 3, and I need to go to LAN 4. Okay, I call this LAN 5. Now, on router 0, I don't need to set for LAN 1 and LAN 5 because those two are directly connected. Do you see here? So it is quite troublesome. Another example, let's say if I want to configure for router 1, okay? How many static route I need to set? Okay, you see, for router 1, I need to set the first one to LAN 1, the second one to LAN 3, and the third one to LAN 4. Here, here, and here. Now, I don't have to set for LAN 2 because it is already directly connected. I don't have to set for the LAN 5 because it is directly connected. Oops, let me refresh this. It is not updating in the stream. Okay guys, don't worry, I will explain this again because without that you cannot understand. Okay, now let's do this again. Technological problem, all these technical problem, but I'm used to it. Okay, let me just highlight this one back for you. Okay, so what I was saying is that how many route you need to know when you want to set static route. That is the first thing. Now, of course, I want to give you some freedom here. For those who think you only want to learn static route, okay. For those who think you want to learn dynamic route and static route, okay. For those who want to learn all 3, that's the best. Because there is no right or wrong answer. Even in the final exam, you can answer using static route or dynamic route or default route. All can be correct, okay? So of course, if you ask me, learn everything . So right now, what I'm showing you is for those people who only want to learn static route, okay? If you want to configure a static route for all the network here, you have to do it for all the routers, okay? So let's say in this case, first question, how many router do you need to configure? The answer is 4. Okay, wait, let me remove this. Okay, so later on when you configure routing, doesn't matter what kind of routing you use, you have to configure 1 router, 2 router, 3 router, 4 router. Okay, now I will start with router 0. When I want to configure static routing, the first question you ask yourself is how many static route I need to set. Okay, the rules is directly connected, no need to set. Other than that, you have to set. So in this case, router 0, LAN 1 is directly connected, don't set. LAN 5 is directly connected, don't set. Okay, so for the other is, you have to set one route to LAN 2, set another route to LAN 3, set another route to LAN 4. So 1, 2, 3. Do you see that? This is how you do this systematically. You cannot just randomly, okay, I feel like I want to set this route, then you will miss out some of the route. You have to be systematic. Okay? Now, I give you one more example here. Let's say I want to configure for router 2. How many static route I need to set? Okay, you don't have to guess one, you just look at the diagram. So router 2. LAN 1 do I need to set? Yes, because it is far away. So you need to LAN 1. Do I need to set to LAN 2? Yes, because it is one hop away. There are more than one router, so LAN 2. Do I need to set to LAN 5? No need, because LAN 5 is directly connected. Need to set to LAN 3? Yes. Do I need to set to LAN 4? No need, because LAN 4 is directly connected. So do you see what I'm trying to do here? I am systematically finding out how many static route I need to set for each of the router. Okay? Now, I will show you example on router 3 because I need that example to explain the second reason we want to learn default routing. Okay, now, but more example is good. So now I'm on router 3. Let's see how many static route I need to configure. Okay, so first route, I start with LAN 1. Another way is you can just write this up so that you don't miss anything. Okay, this is another trick that you can learn. You list out all the LAN that you have here. Okay, and then you think one by one, do you need to configure? So if I'm on router 3, to go to LAN 1, there is more than one router in between. I need to set. Go to LAN 2, yes, too far. I need to set. Go to LAN 3, do I need to set? No need, because I'm directly connected already, my LAN 3. So no need. Okay, go to LAN 4, need or not? Need, because it's very far. LAN 5. LAN 5 need to set or not? No need, LAN 5 is here, directly connected. So no need. So in the end, I only need to set 3 static routing on router 3. Do you see how I do this systematically? Okay, Now, next question here. For those who want to set static route, you have to set 3 command. But with default route, I can simplify all these things into one command, one default route. So you see, what happened next is when we set a default routing, we are actually telling the router, it doesn't matter where you want to go. If you do not know how to go, you send to this default router. Okay. Now, in this case, this is a special case where if we configure a default routing here, this network, the green color LAN 3, can go to anywhere, but you don't have to set one command for each of the network that you're trying to get to. And the reason is very simple, because this green color network is called a snub network. Okay. Now let's go back to our example earlier. So when we say stub network, okay, what do I mean by stub network? One way in, one way out. So let's take PC6 as an example. If I want to go from PC6 to PC1, okay, look at this. The packet will go from PC6 to router 3 to router 0 to PC 0. Okay, PC 0. Now, try to remember this. We will try to get a pattern here. So every time anyone from LAN 3 want to talk to someone else, the packet, first one, it will go through router 3 and you go to router 0. Try to remember this. Now, the second example here. If I have PC 6, I try to get to PC 2. So this is how the packet will go. Starting from PC 6, it goes to router 3, it goes to router 0 again, and then it goes to router 1, and then it goes to PC 2. So do you notice that it goes through the same next hop router? So we are starting to get more pattern here. Now, third example here. What if I want to go using the same PC PC 6 to PC 4, which is in the blue color network. So this is how the packet will go. It start here, go here, and then go to PC 4. And again, you notice that it has to go through the same router 0. Okay? So what we can conclude here is that it doesn't matter where you want to go. If you are from LAN 3, the green color one, your packet will always go to router 0. And in this case, we can say that why not, instead of setting 3 static routes, I set only one default route pointing to router 0, and then you get full connectivity. Can you try to get what I mean here? Because this is a special case where it doesn't matter where you want to go. If you are from the green color network, if you go here, you still have to go through here. If you go here, you still go through here. If you go here, you still go through here. So this one becomes the next hop in the default route. Okay, so in this case, we can just set a default route here to point it this way. Do you get what I mean here? Now, of course, I won't do this config for you. You will do this in the lab. I'm just trying to tell you the concept of default routing. Okay, so to conclude, to summarize, initially I need to set 3 static routes from LAN 3 to LAN 1, LAN 3 to LAN 2, LAN 3 to LAN 5. Okay, now with default route, you just set LAN 3 to default route, and you will get the same thing because all your packet, when you do this, all your packet will be sent to router 0. And then because router 0 is connected to all other networks, he will help you to forward the packet to the destination. Do you see? Now, if you can get the concept, it is good, but when you configure, then you will really know what is going on. Okay, So, 2 reasons. Default route, first reason, you set it so that your router has a backup route to a place that he doesn't know how to go to. The second reason is because you want to simplify the configurations. Okay? Now, if you're okay, then we will go back to your playthrough. Let's go back to your last game and then let's finish up this game. I know you have another class programming coming up, so I want to save some of our energy here. And then, yeah, I think Little Orange is also part of my viewer. He's just outside right now. Okay, now let's get back to your last game here. Okay, if you're ready, what we want to do here is to set 4 default routes for all of the router. So we will start one by one. I start with the Asgard router first. Okay, go inside Asgard router, go to the CLI here, configure a default route using IP route 0. I have done this, so I will just do this again. Followed by the next hop IP, which is 200.200.200.1. Okay. Now, if you want to check whether this is done correctly, you can always do a show IP route. Make sure you have this line. And you will see this one, a star. S star, it means that it is a special kind of static routing. Okay, now next you want to, for those who do not know whether you do correctly, you can check here also lah. You should have this activity file. So in this playthrough, you only have 4 points. Okay, every time you configure correctly a default route, you will get 1 point. So now I already get 1 point here. Okay, I go to the Titan router. Next, we do for Titan router. So go inside Titan router. A default route is very easy to set one, but later you will see why you cannot simply set. Okay, do an en config t IP route 0000 Now over here, you have to be careful about what is the next hop IP. Okay, so in this case, I have a visual here. So let me go back to the visual. So now we are setting for the Titan router, and you want to know what is the next hop IP. So you can just zoom in here lah. Titan router is here. Every time the packet go here, and then it will go to this Earth router, right? So this guy here is the next hop IP. Of course, you can say that this guy can be the next hop IP. So here you have two choices. Do you see that? Now remember what about default route is that every time you do not know how to get to a certain place, you will send it to the default route. So you have to choose whether you want to set a default route to the Narnia router from Titan, or you want to set it to Earth. Now let me give you an example. If today the network grow, okay, it grow like that. So it become bigger and bigger. Okay, now if I choose choice number 1, I set the default route to Earth router. Then in the future, when the network is growing, I can still go to all the destination here. Because when I go to Earth, from Earth I will get there eventually. Okay, now if I set default route as Narnia here, so I set it here, means that in the future, when you have more new network and you don't know how to get there because they are new, you will always send it to Narnia because Narnia is the default route. And in this case, do you think you can get to all the new network? Cannot, because Narnia is not connected there. Do you see what I mean? So when you choose who want to be your default router, you have to be careful who you can trust. You always want to set it to a router that is connected to the backbone or the core network. You don't want to set it to a router that is connected to an end network and that's it. So you go to a dead end. You cannot go anywhere else. You have to choose a highway that is connected to many other networks. Do you see what I mean here? So in this case, for the Titan, I will set Earth as the default route. Okay. So what I do here is, I go back to your network here and go into Titan router. You want to set this interface. So it is Ethernet 000 on Earth, this one here. And the IP address is 110.110.1. Okay, so I will go back to Titan router. I put 110.110.110.1. Oops, let me try this again. Okay, now it works. So this is the command for me to set a default route from Titan router. I point it to Earth. Okay, now if you have done so, check the score. You should get 2 points already. See, now you got 2 points already. Okay, if you are following me, you will have 2 points. If you are faster than me, maybe you already get 4 points. Okay, now I will set for Narnia router. So I go into Narnia router. I go to the CLI here. And then do the same thing lor. Config t IP route 0.0.0.0 0.0.0.0, and then you have to decide who you want it to be your next hop. Now for Narnia, it's actually quite simple. There is no one else to choose. It's only Titan, correct? Because there is only one way to go out, which is the Titan. So on here, I will point my next hop to the Titan router using the interface FA01 on Titan. FA01. So find out what is the IP. FA01 is 100.100.100.2. So over here, I will type 100.100.100.2. Press enter. That's it. Okay. Now, if you want to be sure, you can always do a show IP route to check whether you have this line here. So that is how I configure a default route from Narnia pointing to Titan. Okay. Now, only one more to go, which is Moon. So I will go inside the Moon router here. I will configure a default route. So en config t IP route, and as always, you put 80 for a default route, and you have to choose the next hop IP properly. Okay. So going back to the network here, you know that the next hop IP from Moon would be coming from here to here and then go to Earth. So the interface that you want to set as the next hop, okay, just make sure I get the right one. It is E010. Okay, can you see here? E010 here. Okay, so just to be sure everybody is on the same page, you want this IP here. So go into Earth router, find E010. IP is 210.210.210.1. So I put 210.210.210.1. That's it. I think pretty much we are done with the IP default route here. And let's look at the score. If you have 4 out of 4, yes, congratulations. Now all the routers, all 4 routers on this network already have their default route. So you see, if you have done this correctly, you will already get 4 out of 4. And that's what you really need to set. Okay, now if I ask you, what happened? Why do you set this? You can proudly answer that now all my routers has a backup route. So I won't simply throw a packet away if I do not know how to set. That is something that you can be very proud of. Okay. Now I will answer some of your questions from the chat. Then I'll tell you one more thing about why I don't set a default route on the Earth router. Okay. Okay, now Arjun asking a very good question. Only a pro will ask that question, so I think you are pro Arjun. Now, can you have more than one default route? Think about this. Can you have more than one default route? Okay, now you have to go back to the idea of why we had default route in the first place. Okay, why? You see, 2 reasons. One is to make configurations easy. I can set one line instead of a few lines for static route. Another one is as a backup policy. Okay. Now, if I have 2 default route to 2 different places from a router, this will create a bit of confusion because the router will not know. Okay, now I do not know how to go to KL. Should I take this path or that path? This default route or that default route? Okay. So it is not common for you to have many default route, but in fact, the maximum number of default route you can have on a router is 2. Okay, you just need to know this. You can have 2 default route, but you cannot have more than that because it will make the router to be confused. Okay, you want the default route to be the last resort. When you do not know what to do, you go to this person. But you don't want to have too many this kind of person. Just like you cannot have 2 or more girlfriends. Okay. Now for router, you can have 2 default route. That is the maximum. So any other questions about default route, you can ask now. Okay, very good. Pinyan is very smart one. Every time no question one. No question can be good or can be bad. It means that you are really good or you don't know what is going on. I hope you are the first kind. Okay. Now a question is, if you set a route wrongly, how do you delete? So on a Cisco router, the way you delete a route is you have to type the no in front. So for example, okay, look at this example here. I mean the moon here. Let's say I don't want this route. Okay, I want to delete. You have to go to that interface. You cannot delete from the level 3. You have to go to level 4. So for example, if I want to delete this route here, I have to, I think no need. You can just do this. Let me try. So no 68.1.0. Let's see if it works. You can just add a no in front. Yeah, that's how you do it. So you can do it on level 3. Sorry about that. Do it in level 3. So you type the same command that you set this route, and then you add the no in front. If you press enter, then it will remove the route. So if I do another show IP route, you see that now the path, the route to the first 1.0 is gone. Okay, so this is how you delete a path that you have accidentally set wrongly. So of course I want to put this back. Oops. Okay, now let me see what else do you have. Okay, now hijacker is asking, when should you use RIPv1? I hope I get your answer, your questions correctly. If you mean different thing, you please retype your question. Okay, so like I said earlier, there is no control. You can choose to use static route or dynamic route. Okay, but the recommendation is, if you only have 2 networks that you want to connect, you use static route. If you have more than 2 networks, you use a dynamic route, which is RIPv1. Okay. Now, Azul is asking a very good question again. Now, RIPv1 only work for all the router that is configured with v1. Yes, you are correct. So let me visualize this for you. Okay, I go back to the network here. So this is the network that we have earlier, and then we have already set RIP in 3 routers. Okay, so we set RIP here. We also set RIP here. We also set RIP here. But this one and this one, I should be using different color. This one we didn't set RIP. This one we didn't set RIP. So when the packet, the table exchange happen, okay, when router try to learn from each other, only those who are configured with RIP will talk to each other. So in our example here, these 3 routers, they will exchange the table. But the other 2 routers that is not configured with RIP, they will not receive any table. Okay, so you are correct. Only the router configured with RIP will be able to participate in the routing table exchange, and only you will see the R appear in the routing table. Okay. Okay, now next question here. Can I set all router with default route just for backup? PokeCon, you are correct. In fact, you are supposed to. Okay, like what I said earlier, without a default route, when your router don't know how to get to a certain network, this packet will be thrown away, which is going to create a lot of packet. You are wasting a lot of bandwidth because you're throwing packet away, and then the sender will try to resend because he doesn't know why I cannot send, so he will be resending. So you have a lot of packet retransmissions on the network, which is not good for network performance. That's one thing. The second thing is your reachability is not good. That means you only know how to go to certain place. For the place that you doesn't know how, you don't want to know. That's not right. You're supposed to go and learn about it. So if default route, you should always set it on all of your routers, except a special case where I want to show you in a short while. Okay. Now, can I configure static route and dynamic route on the same router? Yeah, that's very good question. You can configure many routes to the same destination, but the router will only choose one route based on what we call the administrative distance. So I'll explain about the admin distance right now. Okay, no, before that, I will tell you why I don't set default routing on Earth. And the last thing we will cover today is what we call the administrative distance inside the routing table. So let's get back to your network here first. And I want you to look at the Earth router, which is quite odd because that's the only router that we don't set a default route. Okay, now, remember the reason of default route is if you do not know how to get to a certain place, you want to send it to that next router. And of course, you can argue this reason you might not agree, but the reason I don't set a default route is because we cannot predict actually in the future how will the network grow. Okay, so if I am Earth here, if I set my default route to Asgard, okay, and today I want to go to a network that I do not know how, that packet will always go to Asgard router. And this is a dead end because in Asgard router, I cannot go any further. There is no other network. Okay. Now, if I set this default route from Earth to Titan, okay, let's say I do not know how to get to a new network, the packet will always go to Titan router. Okay. Now, if the new network is somewhere here, let's say it is here, then you cannot go already because you accidentally send it to Titan, and Titan is not connected to that new network. So the reason I don't set default route on Earth is because I cannot predict in the future how the network will become. So one thing that can happen is because okay now we have a lot of new network here, or maybe you have a lot of new network here. Okay. So you see, if I choose a default route from Earth, I set it to Moon, then I open up all the way here. But I cannot go here if I don't set any routing, if I just rely on the default route. Okay? Which is actually how the internet works because most of the routers are based on their default route. Now, if I set the other way around, I set Earth default route to Titan, then I can go here. But all the other new network here, I cannot go. So in this case, it is best if you don't set a default route. Okay, now the same logic apply to our example earlier. So when we set a default routing on Titan, remember just now we set a default routing here, we set it to Earth. That is also quite dangerous because what if one day all the new network expanded from here? Then Titan cannot go here already. Do you see what I mean? So of course, it will be confusing. If you think it is confusing, you are correct because to set a default route is not that simple. You have to find out whether it is the stub network. That is the safest place you can configure a default route. And also, if you want to have a backup, you have to bet like the next hop router that you choose as a default route is really the router that can connect to the internet. Okay, I hope you get what I'm trying to say here. So you should only configure default route if you are confident that this won't give you any issues on the network. Okay. So that is basically all you need to know about default route. In fact, we have covered all of the routing. We have learned how to set a static route. And the tricky part is only to find out what is the correct next hop IP which I believe you already know how. We have already learned about RIPv1, and the trick is you only need to find out what is a directly connected network by doing the show IP route command, and then you check on the routing table. And then you have also learned about default route, which is all 0, 40 followed by another 40, and that is very helpful to simplify your routing configurations. Okay, now if you do not have any further questions, we'll go back to your slides, and then we'll finish up the whole things about routing by looking one last time on the routing table. Okay, so I need you to open up your slides. Just give me a moment, the slide is still loading here. So why not you take a 2-minute break? I forget to give you a break. Oh, I think I got too excited today. Never mind, we'll take a 2-minute break here, and then when you come back, we'll finish off your slide, and then you can start to prepare for your lab test. Okay, so 2 minutes. Okay, I think 2 minutes already. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, 2 minutes already. Let's continue. Just one more slides, 2 more slides to go, and then you can take a break before your programming class. So yeah, we are back to the slides, and what you're seeing here is the routing table. So if you remember, when we started about routing, this is what we learned. So we learned about what is a routing table and what is the content that you have in the routing table. Okay, but okay, you see it is quite different from when you see a real routing table in Packet Tracer. It's all text-based, which is correct. Now, of course, because router is actually we design router solely for forwarding packets, and there isn't really any UI that is built in on the router. So of course, it cannot be like a table like what you are seeing here, lah. Okay, so the real routing table looks like this. This is the real routing table. So you might be thinking, hey, you know what this made me feel? It feels like every time when I open the fridge, I want to get some ice cream, and then I saw a box of ice cream, and then I open the box. It is not ice cream inside, it is all the prawn that my mom keep inside. That kind of feeling, okay? So this is also true for routing table. It looks very simple, but what are the content inside? You have to know them very well. So in fact, I'll just quickly go through with you. What do we have here? So just as a recap, the very first thing you have will be the codes. Now, I'm blocking the view, so I want to move here. Now, all the code will tell you this route, what is the route, what is the type of the route, whether it is static route or is it a dynamic route. And if it is dynamic route, what kind of dynamic routing? Because there are many kind of dynamic routing. Okay, you have RIPv1, RIPv2, OSPF, BGP, ISIS. So many, I cannot name all of them here. Otherwise, this room will be 3 hours. But okay, what you are learning right now is RIPv1. And for those who are interested to know more, you can actually see on top. So all this code here will tell you what is the route, what are the type of route. So when you see an S, you know, okay, this is a static route. When you see a B, you know, okay, this is a BGP route. Okay, something like this. So, okay, now, somehow I have some visitor outside. Wait, don't worry. Next thing, what's important in the routing table is all the network destination. Okay, so over here, what you're seeing here are the network that we are trying to get to. Okay, do you see this? Now, of course, this is one of the most important things because the whole point of having a routing table is to teach the router how to get to a certain place. And this one is the destination. Okay, now, in some cases, you will see that Y that are similar or the same network address. Okay, means that Y to go to KL, I have 3 lines. Supposed to only have 1, right? So why I have 3? Because remember, there are many ways you can take to go to a same destination. So for example, right now I'm in Kampa, okay? I can get to KL by taking train. If I'm a smart consumer, I'll take train because that's the cheapest option. Or if I want to show off, I want to take some Insta story, then I'll take the flight from Ipoh airport to KL because taking flight is more Instagram worthy, right? So that is something that you can think of if you want to get more view. And then I can also say, hey, why not you fetch me lah? I have so many friends from KL, just fetch me and then but normally I don't want to do that lah because it's too fast for me. My friend drive a little bit too fast for me. So the point is, there are so many ways you can get from one place to another. And it is true for router, okay? So sometimes when you see a few lines to the same network, it is correct, it is not wrong, okay? The only problem is that the router have to think, which one should I take, okay? Now for example, you don't have an example here, so I will write an extra example here for you. So let's say, you have a routing table that looks like this. So let me refresh the screen. So I have one routing table and then it showed me something like this. Okay, now in this case, what the router is trying to do is, he know that he will have a few options. So to get there, I have to pick the best one. So one of the job of router is to pick the best path to get from one place to another. Okay, remember 2 jobs. The first job is to forward packet from source to destination. The second is by using the best path. So best path can be many. You can say best path in terms of fastest path, or the path with the less number of router in between. So there are many ways they say this is the best. Okay, we don't care. So let's say in this example, which path do you think the router will take? Okay, you don't have to think. You can see directly. So the trick here is, router will always choose the best path by looking at this number. And this number is called the administrative distance. Okay, if you go back a few slides up, okay, I want you to go to slide, wait, let me find the slide number. Okay, slide number 5. Now in slide number 5, this is where you learn about admin distance. Okay, this is quite important. I highlight this for you. So again, why we have this number? Reason is, sometimes there can be a few paths to the same place and the router have to choose one, and the way router choose is by looking at this number. Okay, so the algorithm is, the router will always choose the path with the smallest number here, the smallest value here. Okay, remember we want to give priority to the route with a smaller number of AD value, which is the administrative distance. Now if you go back to my example earlier, which path do you think the router will pick? So you have to see, over here, what number is the smaller? This one, number 1 of course is smaller, so this is the first choice. If this one is gone, then this is the second choice. If this one is gone, then this is the third choice. Do you see? So this is how router will decide. And all this number here, by default, every routing protocol will be given a number. And I will show you the number here. If you look at the diagram here on the screen, you can see there's a table, right? Now this table is showing you all the default value of the admin distance. Okay, now what I mean is, if you get a new router out of the box, this is the number that is already coded inside the router. Which means that if you have a few paths to the same place, they will refer to this number to make the decision who has the priority. Okay, but you should know that this number can be changed. So if you are not happy about this current default value, you can always change it to some other number, and then your router will choose different path based on the new number that you set. Okay, now one more thing I want you to look at is, can you please look at this table here on my left? That is static route with AD1. Means what? 1 is the smaller value, smallest value. So this is why every time router choose, you will always choose static routing first. If you have any other options, it will come after static route. Because by default, static route has admin value of 1. Okay, now I don't talk about the default route, the directly connected, because it's 0, it's no routing. Now, next one, how about default route? Just now we learned about 0, 0, 0, 0, that is the default route. Okay, that one is always the last choice. Meaning that if you go through all the table, really, there is no way for you to get that, then only you use the default route. And default route is, remember, the last choice. The static route is always the first choice, based on the table that you see on the screen right now. Do you get what I mean? So that pretty much sums up everything that you need to know about routing. And simply, routing is just how to get packet from one place to another place. And this is done by router. And how the router works is by looking at routing table. And what you have learned is really cool. You already know how to see the routing table. You already know how to set up routing, which is what only a pro can do. And you also understand about the admin distance that we just talked about. Okay, so just one more quick questions here. Quick question, if you can answer this, then I'll let you go. What if I have this thing here? Okay, tell me, if I have this, tell me which path do you think it will take? This is too easy. Let me make it a little bit harder for you. Okay guys, now on the screen here you see 2 routes. Can you tell me which route will the router take? Oops, sorry, let me erase this. Okay, please tell me which path will the router take? What do you think? You should be able to see right now on the screen there are 2 routes to the same destination network. So it's very simple. Which path do you think the router will take? Now to answer this question, always go back to the rules. Router will always check what is the smallest AD value. Now the smallest AD value based on the table is, again, let me check. If I use R is RIP. So RIP is having 120. So this is 120 here. And then BGP is having 20 here. So naturally, the router will always pick BGP. This is the one that wins because the AD value is smaller. Okay, that is how router decide. Very smart. So router can decide. How about you? You decide want to get A for datacom? If so, Now after this stream, please start your revision for your lab. Okay, until then, see you. Peace out.
Whatever happens, predictability.